The function u is to be thought of as the inside function. Basically, composition of functions means you evaluate one function and you get an answer, and you take that answer and then evaluate the next function at that answer. That's how composition works. So the inside function, the first one that you would evaluate is the u. So we let u equal 8x squared minus 2x plus 3. Because we know how to find the derivative of 8x squared minus 2x plus 3. That's no trouble. We might not want to raise that to the fourth power. That's a real pain to raise a trinomial to the third power and multiply all that out. But we know how to do this. Then y equals u to the fourth power. If we pick all that stuff up out of the parentheses and put a u in there, then that's u to the fourth power. So if we have u in terms of x and y in terms of u, we can find du dx, and we can also find dy du. Is this the first time we've talked about dy du? Independent variable is different, but it's the same idea. The derivative of y with respect to u. So this is going to be 16x minus 2. And dy du is 4u cubed. So we write the formula. Dy dx equals dy du times du dx, and then we multiply. Dy dx equals 4u cubed times the quantity 16x minus 2. Guess I don't need the dot there if I'm going to use parentheses. 16x minus 2. Except that our final answer doesn't need to have any u's in it. The original expression didn't have any u's in it, so our final answer doesn't have any u's. The u is just something that we made up to make the calculation simpler. So the final answer, substitute that expression back for u. So dy dx is going to be 4 times 8x squared minus 2x plus 3 to the third power times 16x minus 2. We can simplify that further. It just gets tedious from here. You could factor a 2 out of the 16x minus 2. Then you take that 2 and multiply it by the 4 out in front. But as far as the substance of this, we've calculated the derivative and almost simplified it completely. Now, the thing I guess I should point out here, if we didn't know about the chain rule and we're just looking at this expression, we might just think power rule. Because what we have is an expression raised to a power. We've got 8x squared minus 2x plus 3 quantity to the fourth power. And it would seem like just use the power rule. Take that 4, bring it out in front, reduce the exponent by 1, and if we did that, we would get, different color, like that, we would get this. That's what we'd get. We'd be off by, a bit. There's the 16x minus 2 that we'd have to contend with. But where does the 16x minus 2 come from? How could you look at this expression right here and come up with 16x minus 2? It's the derivative of that. So the chain rule is going to talk to us for the rest of the semester. For the rest of the semester, you're going to hear me say, and the chain rule says, multiply by the derivative of what's inside the parentheses. That's what the chain rule is going to tell us. Because you take the derivative kind of like you would expect to. The derivative is something raised to a power. You take that power, bring it out front, reduce the exponent by 1. But The chain rule says multiply by the derivative of what's inside the parentheses. Basically, multiply by du dx, the derivative of the inside function. And when we do that, we'll have it. So in practice, we won't write the u, and we won't calculate the dy du and the du dx separately. We'll just deal with this in terms of f's and g's and x's, because it takes too long to write all this down. But that's kind of what's going on. We take the derivative of the outside function, and then we multiply by the derivative of what's inside the parentheses.